You're welcome back to our class. We'll be looking at ambiguous cases where our sign rule is being applied. We are taking a look at this triangle. It's quite a complex triangle. We are looking for the angle marked at C1 and angle marked at C2. Like we earlier established using the sign rule, you have to look for pair of opposite matching sides. For angle B, we have a matching opposite side at 3. Then angle C1, we have a matching opposite side at C1. Or you can use the bigger triangle, which is angle A, B, C. This triangle can be used. Okay, so in this triangle, I can use the matching opposite side as 3 and the matching opposite side of C2 as 4. So any one of these will be able to give you C1 or C2. So for this triangle, I have my B angle at 44 degrees, and I have side B as 3. Then I have opposite to my C1. You can see C1 here. Angle is at theta. And the side of C1, we have 4. So what are we looking for? We're looking for the angle marked theta at C1. So applying the sign rule, which we earlier established, that B over sine B equals C divided by sine of C. So my B is 3 divided by sine of 44 equals 4 divided by sine of theta. So we've gotten the equation. So what do we do from here? We have to cross multiply in order to find our sine of angles. So we have 3 sine theta equals 4 sine 44. So since we are looking for sine theta, I'll divide both equations by 3 and 3. So on your calculator, we have 4 sine 44, which is equal to 2.7786, approximately 2.779. So divided by 3. So you divide that by 3, what do we have? We have sine theta as 0.9262. But take note, we are looking for theta and not sine theta. So what do we do to find theta of angles? So our theta becomes sine inverse of 0.9262. So on your calculator, how to find your sine inverse? You press the shift function on your calculator and you press sine and you press 0.9262, which gives us 67.85. So your angle marked at C1 is 67.85. You have to take note at this rule here. The sine rule will give you 2 possible values. 2 possible values for the solution of any missing angle. So you apply sine theta is equal to sine 180 degrees minus theta. You are going to have 2 possible values for your angles. So we have 67.85 for the first angle, which can be approximated as 68 degrees. So we have 68 degrees, or you can leave it at 67.9 degrees. Any one of them will serve to find the other angle. So choosing any of those values, I'm going to use my 180 minus theta to find the other values of theta. So that will be 180 minus, I'll go with 67.9 degrees. So when you have 180 minus 67.9, we have 112.1 degrees, which is approximately 112 degrees. So now we have established our theta values. Theta is either 67.9 degrees or 112.1 degrees. Going back to the triangle, you can look at this triangle here. This angle marked here is an obtuse angle. This is an obtuse angle, and the values of obtuse angle are greater than 67 or whatever you have. So the only value that can fit in perfectly to your obtuse angle is 112 degrees. So we go with our C1 here, becomes 112 degrees. So having gotten that, what becomes our C2? So since we've gotten two values for C, which is 67.9 or 112.1. So one of those values is going to serve here, which will give me 67.9 degrees. So that is how we go for this particular case using our sine rule applications. So we'll move further to another example, applying the sine rule theorem.